Hello friends, today we are going to see the how to solve the Ansys problem of composite truss. That is the truss consisting two different element. So for that, first launch the mechanical FPDL product launcher. You can see here the window. You can run the software. Now, today we are going to see the composite truss problem consisting two different material having two elasticities, two different areas. So for that you need to define the two different elements, two different materials for that truss. So first go to preferences, then select structural, then click OK, then go to preprocessor. In that element type, add, edit or delete. Now you can see here a window consisting, so you need to click over the add. As you here you can see different options, so you need to, as it is truss, you need to select the link over there and you can say OK, then close. Now go to real constant. In that, add, edit or delete. Now first you need to add the first set of real constant, like that is the add. Then you can click the element type OK. Then here you can see the real constant set number 1. Here for first material you are going to give the area for that, so I am giving the area to 3250 mm square. Then I will select the apply, as I have to give the second set also, as I have two material, I have two combination of I have the combination of two different materials, so I will give the second set of material and I will again select the area as 3250, then click over OK and then close. Now you you can go to, now you have to go to material properties in that material model. So first for that, for first material, define the material properties like structural, elastic, structural, linear, elastic and isotropic. In that first elasticity, modulus of elasticity, I will select 2e5 and Poisson ratio I am selecting 2033 0.33. So after that I will go to material, I will select new model, so I will click over OK and then I will again select, I will give the elasticity and Poisson's ratio for the second material, that is 0.7 E5 and 0.33. Okay, then you can exit from this window. Now you have given the material properties, real constant and element type for the truss. Now you need to actually draw the truss. So for that you have to go to modeling, in that create, in that you need to go to nodes, in that you need to go to inactive CS. So first node is 1 and the location is 000. So for that I am applying the node. Then second node, I'm taking the location as 1800 and height I'm taking 3118 and it is 0. So applying, by applying you can here easily see that the node number 2 is arrived. So now the third node, and the location is 3600 and y coordinate is 0. So by applying you can see here the node number 3. Now node number 4, similarly I am plotting all the nodes, different nodes. So node number 4 is at 5400, it's 3118 and by applying you can see the node number 4. Similarly node number 5, it is at 7200 and the y coordinate is 0. So after applying After applying, you can select here OK. So here we can draw the truss. So suppose now I need to join this truss, these nodes by an element. So first of all, suppose 1 3, the element 1 3 and 3 5 and 2 4 are of element, are of material 1, and remaining elements are of material 2. So for that, you can go to attach this nodes. You can go to element. In that element attribute, first make sure that here is the number 1 is appearing, here also 1, here also 1, and first you can say OK. Then in that auto number, then through nodes, now our link 1 to 3 and 3 to 5 and 2 to 4, these are of first kind, that is first type of material. So for that I am taking those three links, 1 to 2, 3 to 5 and 2 to 4. And okay, these are the elements of first material. So now I am again going to element attribute, then I will change the material number, as I have already defined the second set of material. So for that I am selecting the second material number. Here real constant set number I am selecting 2, and then OK. Then I will go to auto number, then through nodes. Now these links, remaining links, are of material 2. So I am joining these links, and here I have joined this link, and in this way this is the basic structure which I have to analyze in this software. So now I have completed with the geometry of the truss, composite truss. In that 1 to 2, 2 to 3, 3 to 4 and 4 to 5 are of one material, and 1 to 3 and 3 to 5 and 2 to 4 are of second material. So now I have to apply the boundary condition, or you can say degrees of freedom at the node point. So for that I am going to um loads. In that, first make sure that analysis type, the new analysis should be static over there. Then and then you can go to define the loads. So go to define load, then click over apply. In that structural, in that displacement, so now on nodes, so on first node the displacements are, so first node, then click or apply. Then you can select here all degrees of freedom, as first node consisting all degrees of freedom at 0. So I am giving that, then applying. Then at the fifth node I have to go to, here is a roller support. Actually at this fifth node there is roller support. So for that roller support, there is only deflection in x direction. So you can constrain the motion in y and z direction. For that I will select the node number 5 and then apply. Then I will select the y and z direction and make their displacement value as 0, so that the beam only can travel around the along the x direction. So after clicking that, here is a constraint motion I have given to the truss. Now I need to apply the force over there. So first of all, the force, I will go to structural, again define loads, apply structural. In that force or moment on nodes, I will select the first node, then click or apply. Then my load is along the y direction, so considering fy, and in downward direction, so minus 280. I am giving this load arbitrarily as minus 280 on the first node. So by applying, you can select, see here the load of minus 280 Newton is applied over there. Now I will select the second point over there, and second node, apply, then fy, then value I will take 210, and after applying you can get this. Then at third node point I will give the value as 280. So after clicking OK, here are the loads. I have given to the truss. Also there are displacement also I have given to the truss. Now I have to go to, so now I have to go to solve solution of the problem. So first here you have completed with geometry and apply application of different loads. So first go, now you need to go, you need to solve this problem. You need to analyze this truss. So for that, go to solution, in that solve, in that current ls, and after clicking OK, you can see here the solution is done, and in this way the solution of the truss is obtained. To analyze the result of this solution, you can go to general post procedure, in that plot result in that deform shape, and you can select here deform plus undeform, and after clicking OK, you can see here, easily see the deform shape of that truss. So in this way, we can go to, we can solve the problem of composite truss, and in this way we are, so thank you. Okay.